In this video, we will discuss about SQL Server Query Optimizer, deriving estimates utilizing multi-column statistics for queries. It has got more than one predicate. I'm going to use database AdventureWorks TW for this demo. I'm going to create a table called table1 underscore temp that basically gets its data from a backup table called table1. What I'm going to do now is I'm going to execute this particular query to list out all the statistics that is present on table1 underscore temp. So in this case, I don't see any statistics created as of now. So now what I'm going to do is I'm going to create two statistics. The first one would be a multi-column statistics called multi underscore column 2 underscore column 3, and it will be created on table 1 underscore 10, and the columns would be column 2 comma column 3. So and then the next statistics would be on column 3 for table 1 underscore temp. As far as the multi-column statistics is concerned, when you look at the histogram, you will understand that the values as far as the range high key in the histogram is actually derived from the leftmost column, and in our case it is going to be column 2. Yeah. So now let's execute the query to check the available statistics. What we are able to see is we are able to see the multi-column statistics that is present on column 2 and column 3, and then a single column statistics stat underscore col 3, which is basically on column 3. Now what we'll do is we will try executing this particular select query, which basically returns all the rows. It basically returns the count of all the rows from table 1 underscore temp, with predicates column 2 is equal to Ramesh and column 3 is equal to 439. So let's execute that query. Let's include the execution plan and then execute that query. Now let's look at the execution plan. What we are able to see is we have a table scan happening on the object table 1 underscore temp. If I hover my mouse on table 1 underscore temp table scan operator, I'm able to see that we have an estimate of 133.7. So we have an estimate of 133.7. Let's verify that one more time. It is the estimated number of rows per execution is 133.735. So I've noted it down as 133.7. Yep. So now what I'm going to do is I'm going to list out all the statistics that is present on this particular table. And as far as queries, where query optimizer is basically going to derive the estimates utilizing multi-column statistics on select queries that has got more than one predicate. What we basically do is we follow this particular calculation. So what we basically do is we first calculate the density value of predicate 1 and predicate 2. So in our case, predicate 1 is column 2 and predicate 2 is column 3. So what we basically do is we get a minimum value. So basically what we do is we get the predicate 1 and predicate 2's selectivity value. Once the selectivity value is in place, what we basically do is we get a minimum of the density value, and then what we do is we will basically be multiplying the selectivity value of P1 and P2, and then out of this minimum of density and then the selectivity value of predicate P1 and P2 multiplication, we will find the maximum value, and then that maximum value will be multiplied by the number of rows that we have in table 1 underscore temp. It is going to be a little tricky initially, but as soon as we complete the calculation, it will be comparably easy. So now what I'm going to do is now that we know we have two statistics, which one is the multi-column statistics, which is on column 2 comma column 3, and the next one is a single column statistics, which is stat underscore col 3 on column col 3. Now what I'm going to do is I'm going to run the DBCC show statistics for the multi-column statistics. Let's run that across, and then we know that the value for call to is Ramesh, but now what I'm going to do is like for this multi-column statistics, I'm going to get the all density value. So in this case, the all density value for this multi-column statistics is this one. If we see here, we have the columns column 2 and column 3. So I'm going to take this one and I'm going to replace that. Yeah, yep. So now let's calculate the selectivity value for predicate 1, which is basically column 2 is equal to Ramesh. So what we'll do is like we will calculate the selectivity value. So we have this value of Ramesh. So let's see if there is an direct hit on the histogram as far as value Ramesh is concerned. So if I see here, what I'm able to see is like there is a direct hit, and then the EQ rows is basically 302. So the way that we calculate the selectivity value is like we basically divide the number of rows on table 1 underscore temp that passes through the predicate column 2 is equal to Ramesh divided by total number of rows on that particular table, which is table 1 underscore temp. So what we'll do is like we will calculate the selectivity value, and then we will put it here. So P1 is 0.00254016, and that all density value for this particular multi-column statistics is this one. So now what we'll do is like we will do the same thing as far as this one is concerned. Let's look at the histogram values for statistics stat underscore call 3. And the value that we are looking, the predicate is basically 439. So what we'll do is like, let's see if there is a direct hit for 439. So we don't have a direct hit for 439. Basically, the value 439 is buried between histogram step 98 and 99. So the value 439 is between range I key 438 and 442. So what I'll do is like I'll take the average range rows, which is 148, and then divide that by the number of rows we have on this particular table to get the selectivity value. So if I execute that, here we get the selectivity value, which is basically 0.00124484. So now that we have all the required values, we will get the total number of rows as well. So now, as far as the multi-column statistics is concerned, the all density value is this one. The selectivity value for column 2 is basically this one, and then the selectivity value for predicate 2, which is P2, is basically this one, and the total number of rows is this. So now what we'll do is like we will take this particular formula and then let's do the calculation and then see if we can get the required value. So the so the formula is max minimum of all density of two columns P1 comma P2, and then we have P1 multiplied by P2 and then number of rows. So what we'll basically do is like we will put in the all density value of two columns and then the selectivity value of predicate 1 and then selectivity value of predicate 2, and then we will find the minimum of these three values. And then what we will do is like we will calculate the selectivity value of P1 and P2 and multiply that. And then what we do is like we will find the maximum of this and this. And once we have that, we multiply that with the number of rows. Okay. So now what we'll do is like for all density of two columns, this is the all density of two columns. So what we'll do is like we will put that here. And then as far as P1 is concerned, this is the predicate 1. So we copy this and then put it here. And as far as predicate 2 is concerned, this is the one. So we will put that here. Sorry, we'll put that here. And then again, we will put P1 and P2 here. One, P2 here, and the total number of rows is this one. So we'll put it here. So what we'll do first, we'll collect we will see the minimum of these three values. The minimum of these three values is this one. If you see here, this is 0011, this is 002, so this is greater than this, and this one is 0012, but this is 0011. So what we will do is like we will use this one here, and then we will put it here. So as far as the minimum of these three values are concerned, we will have this value. So we will take this one and put it here. And as far as P1 into P2 is concerned, it is still there. So we have found the minimum of these three values, which is this one. And now what we'll do is like we will calculate this one here. So we basically have to multiply these two values. So if you multiply these two things, you get this particular value here. So what you will do, you will basically find a maximum. So this is the value. So what you will do is like we will basically put this particular value that we have selected here. So now what we'll do is like we will find the maximum of these two values. I'm pretty sure the maximum of these two is definitely this one. So I will take this one and then multiply that with the total number of rows, which is basically this one. So the maximum of this is this. So let's multiply that. So we are getting a value of 133.73. So if we look at the estimate here, that shows as 133.7, which seems to be same as our calculation. So what we will do is like we will execute these two queries side by side, and then we will see the value here. So if I see here, um, for this query where I'm trying to return all the row count for from table 1 underscore temp, where the predicate column 2 is equal to Ramesh and column 3 is equal to 439, and I have a multi-column statistics on column 2 comma column 3 and the single column statistics on column 3. Now if I look at the estimates here, it basically tells like the estimated number of rows per execution is 133.73, and if you see here, it is exactly the same, 133.73. So this is the way how optimizer performs the calculation in case if we are the optimizer is deriving the estimates using multi-column statistics for queries that has got more than one predicate. Yep. So now just a recap, what I will do is like what we have done is like we found the all density value for the multi-column statistics. In our case, it was this one. So we calculated the density value, and then what we have done is like we calculated the selectivity value by dividing the number of rows for table 1 underscore temp with a predicate of column 2 is equal to Ramesh, the number of rows that passes through this predicate divided by total number of rows, and this is the value that we got as far as selectivity of P1 is concerned. And for the selectivity of column 3 is concerned, we utilized this one and we did the same calculation and we got this value. And the total number of rows on table 1 underscore temp is this value. So the formula is basically we find a minimum value of first one, all density, and then the selectivity of predicate 1 and selectivity of predicate 2. Once we have the minimum value, what we do is like we try to find the maximum of this one, and then the resultant of selectivity values of predicate 1 multiplied by selectivity of predicate 2. We find a maximum of these two, and then once we have it, we basically multiply that with the number of rows that we have on the table. So that's the calculation for deriving the estimates for the query optimizer using multi-column statistics where the select query has more than one predicate. That's it for this video. Thanks for watching. Have a great day. Jai Hind.